Hello. In this video, we'll learn about assembly-based cost estimates. And in previous videos, we'll learn about cost estimating, and one type of cost estimating is rough order of magnitude. And we'll see now the second type, which is assembly-based estimating, which kind of covers conceptual, preliminary, all different design or estimates that are done during the design phase with different levels of available design information. So we'll learn about the application of assembly-based estimating and the use of RSMeans as a reference to do assembly-based estimates. So what is an assembly? An assembly is a grouping of individual work items with appropriate quantities to provide the cost for a major construction component in a way that's convenient to measure and also provides a level of acceptable accuracy. So an assembly can be like exterior wall or flooring system. So it can present levels of different degrees of detailing in the building. So assembly-based estimates uses tracks the scope or quantifies the scope by assemblies and look at unit rates or cost rates defined also by the assemblies. So they're used now to verify the cost impact of different design changes or alternatives, or also they can be used to adjust the models that are used in the square foot cost estimates and rough order of magnitude estimates, because if the model that's providing the square foot cost is not really matching with what you have. In the case of the building you're designing, you have some design information, so you can use that with the assemblies and their cost rates to adjust your square foot cost. So assembly-based estimates do not require full design, although they require some level or partial design information. And they can do it at different points in design. So when you have very few design information, then it's called conceptual. Some people mix conceptual with preliminary, that's fine. And then you have definitive estimate. Some people in the industry skip all these names and just say 10% design estimate or 50% design estimate. So this is kind of the new language now. Regardless of the name of the estimate, you're depending on what level of design information and drawings you have. And typically, using this partial design package, you will use assembly-based approach to develop cost estimates. So assembly-based cost data that in this course I will share some page of it will be coming from RSMeans square foot costs book, and I'll see some snapshot of this in the next slides. So now these assemblies and their cost data need to be organized in a very standard way. So you move the data and use them between different projects, and even that standardized way of organizing the data can be used between companies. And you do research studies about what changes the cost from this project to this project. So you normalize here the practice of representing assemblies and also representing their data. So uniformat is the way, like we discussed before. There are different standard building classification systems. Uniformat and master format are the most famous ones, especially in the US. They're following here an ASTM standard. So uniformat looks at the building as a bunch of systems and subsystems and components. So there are 6 main systems, and every system is broken down into subsystems and then at the end components. And you can see here the coding system used for that. So following uniformat, RSMeans provide assembly cost data over many pages. This is one page under A10 system, which is the foundation system. Under it, there's the standard foundation, and we're covering here, or we're looking at the assembly called wall foundations. And you need to look here at and check the assembly graphic provided so you understand what's really covered by this assembly. You can read the description here because this assembly, the cost estimate for it, is done based on a lot of assumptions that the RSMeans staff did and research kind of did to organize the data they collect from contractors and on their costs. So if, for example, this wall foundation is a load-bearing system, so and it's up to 6 feet high. This is the strength of the concrete. It's vibrated and placed. The wall systems can be from 6. The thickness can be from 6-inch all the way to 16-inch, and they are designed with minimum reinforcement. So they tell you that you don't expect. This is a typical wall for typical loads with minimal reinforcement. They also kind of always look for exclusions. So excavation and backfill are not included. So this is the case where you're only looking at the building of that foundation, but reaching to the level of foundation is not included. And you see here, you see the reference section for further design and cost information. This is a different page in the book. So another thing here is you look at the coding system here. So A1010, and then 105 is referring to the wall foundations. So it's a 12-character identifier. So the first couple of them are the standard uniformat classification system coding. And then the rest here, these are more detailed classifications of different types. So for the wall here, you're looking at the wall height. What's the placement here method? So is it by the direct chute, or basically letting the concrete go through a chute from the truck to the formwork, or are you pumping it? And then this is the concrete cubic yard per linear foot. How big is this foundation, and how heavy reinforced it is, and the thickness. And then you're given here the costs as unit costs. Remember, this is a unit per what? What's the unit here? It's cost per linear foot. So this cross section now that you define and the type of material and the way you construct it, now you're measuring your foundation by linear foot. And this is a wall footing, so it's a linear kind of structure or assembly. So they kind of detail it by material. So, and then installation, meaning labor and equipment, and then total cost. So pretty simple. In some pages, you'll find much simpler kind of classification of elements under this assembly. This one is a little kind of considering multiple factors. So this is an example of how a full estimate is done, but not for a big project, is done by assemblies, assembly-based cost estimate. So you see here, that's an interior fit out. So you have partitions, painting, carpet, light fixtures, and switches. So you do all that, you look for the assemblies. This is the assembly numbers or codes. You get the square foot, the units and their quantities, and you calculate the subtotal. So this is the cost. Then you add overhead. So you add sales tax if it's applicable in this project, general requirements, overhead, and then profit. And then you can add architect fee and contingency. So if you are kind of serving an owner in a design firm for working for an owner, then you can, let's say, based on the design information, again, it's not that detailed, it's a couple of lines here, you can give an estimate for this work. And always remember, like one video we covered before, that they need to adjust the cost for time and location. So this estimate here is anywhere kind of the average national estimate for such a project, but you have to adjust for it by city index. If this is done by a book that's, let's say, 2016, and you are currently in 2020, so you need to adjust by construction indices. So just remember that. So that's the end of this video. We'll learn about assembly-based cost estimate. We'll learn about it, but the best way to learn about estimating is to apply it, to do it actually, because you will learn a lot by being comfortable making assumptions. So that's a disclaimer here. I'm not teaching you. You're not done with, you're not an estimator now. You're just learning the way and terminology and different sources that you can use to develop an estimate. But estimating is really something that you learn by doing. So we'll look into exercises when in classroom how to use that, but it's a lot of being comfortable, a lot on you being comfortable making assumptions and reasonable assumptions. So we'll learn why we need to apply assembly-based cost estimating, in what cases, and we see an example of the data available to us in terms of and in the form of RSMeans cost data. Thank you. I will see you in the last and next video of this lesson.